Alright, so some of this is going to be a review from the preliminary preliminary ductwork layout the other day. So the very first thing, if you're going to do a ductwork layout, is you need to figure out where your unit is. You have to know where the ductwork is going to and where it's going to go back to for the return air. You need to identify all the diffusers and registers in the zone. You need to tag all the diffusers and registers with the tag number, like D1 or D2 or D3, as well as the CFM quantity. You need to establish the location of the mains. So where do you want the main ductwork to run? You want to establish the location of the branches. You want to begin to develop takeoffs for each diffuser or register. Seventh step is where we would begin today. Size from end of system back to unit, considering all of duct design rules. So the last thing that we talked about last time we did a preliminary ductwork layout, we talked about getting all the CFM quantities for each section of ductwork. So you should have those at this point. We're only going to work on one system at a time. We're not going to do separate systems. We're going to work on the supply, and then the return, and then the exhaust. You want to try to come up with a system that uses the least amount of ductwork, because ductwork costs money. You want to consider your access. How are you going to actually get to the ductwork if you need to get to the ductwork? You want to avoid very long branch runs. And the way that you're going to avoid having very long branch runs is by locating your mains or your trunk lines in a location that prevents that. And you should also be considering where your return air and exhaust locations are. So a lot of those things are review. There is one other thing that I didn't see on there that's probably on this one, but I'm going to, yeah, it is, number 5. So we'll worry about that whenever we get to it. The very first thing for duct rules, maintain a 4:1 ratio maximum. So just to give you an example of this, if I was going to be doing a ductwork layout and I know that the height of my ductwork is, we'll say, 10 inches to make it easy. So the height of the ductwork is 10 inches. A 4:1 ratio, the widest that could be and still maintain a 4:1 ratio would be 4 times 10, or 40 inches wide. And the whole idea of this, if we go back to number 2, if we look at number 2, the ideal duct shape for the least amount of pressure lost and the best performance and minimal noise is round. So that's the best ductwork for a well-performing system. The next best is oval. The third is square. And the further you get away from square, then the worse the system performs, the more pressure there is. So you want to try to stay as square as possible. So we're going to do that by saying that we don't want to go any more than a 4:1 ratio. Obviously, square would be a 1:1 ratio. And we're not going to do a whole lot of round duct except for our takeoffs, our branches possibly. And we're not going to work on any oval for this assignment. Alright, so whenever you're labeling duct size, you label the first one that you see comes first. So if I had this 40 by 10 in plan view, I'm going to be looking down at it. I'm not going to see the height of this ductwork in plan view. The only thing that I'm going to see is the width. So, like it says, labeling duct size, the size you see comes first. Well, the size I see is the width. So this ductwork would be 40 by 10 supply air. And that's how I would write it. If I had 10 by 40 supply air,
Please excuse the interruption. Representative from South Hill School of Business and Technology is in the multi-purpose room at this time for any interested students. Again, that's a representative from South Hills in the multi-purpose room at this time. Thank you.
so if I had a 10 by 40 supply air duct, that would mean that it's 10 inches wide and 40 inches high, if I'm looking at it in plan view. Most of the time, for HVAC plans, you're looking at ductwork in plan view. Sometimes we'll do some sections or some details, and you have to keep this number 3 in mind whenever you do that. Alright, the next thing, allow at least 2 inches extra for round duct takeoffs from mains. So that means whenever I'm looking at this from the side view, and we'll go back to this one, if I'm going to do a round duct takeoff from this, I'm basically going to have a conical takeoff, and then I'm going to have round duct that connects to that. So I need at least 2 inches. This duct here has to be at least 2 inches smaller than this duct. If it was the same size, then it's not going to be able to have a takeoff coming off of there. So this could be 8-inch maximum. Alright, number 5. When looking at available plenum height, don't forget external insulation for duct size. So this is going to be one of your starting points, really. You're going to look at your ceiling height, you're going to look at the bottom of your joist, and you're going to find out exactly how much space you have in between the top of your ceiling and the bottom of your joist. That's going to be your plenum height. That's the highest that your ductwork can be. If I have 12 inches there, then I can't have ductwork that's higher than 12 inches. Now, with that being said, number 5 says, when looking at the available plenum height, don't forget about external insulation on duct size. So there's 2 different ways that you can insulate ductwork. You can either insulate on the inside or the outside. Regardless of which one you do, you have to add an extra inch on each side to accommodate it. So if I had 12-inch height in my plenum, the highest ductwork that I could actually have would be 10 inches. Alright, the next thing, when drawing flex duct, show no more than 8 feet of length in plan view. And basically the reason for this is if you draw 8 feet in plan view, whenever they actually install it, it's going to be 15 feet long. And you don't want lengths much longer than 15 feet. It can very easily be compressed. You're going to lose some system performance. It's not going to perform as well whenever you have really long stretches of flex duct. Alright, the next thing, try to only transition ductwork in one direction at a time. So if I'm going to change the size of the ductwork, what I need to do is I only want to change the size of it in either width or height. I can do either or, but I don't want to do both at the same time. I want to try to transition in width, and then maybe the next time transition in height, or vice versa. And round duct elbows, this is basically just going to be some notes for you whenever you actually get into start drawing them. This is how you're going to actually draw it on AutoCAD. And I'll explain that as we're doing it. Now, you're going to use approximately 1,000 feet per minute for your static condition when sizing ductwork. And I'm going to show you the next thing. I handed out ductilators to you guys. And this is what you're going to use to size ductwork. So we're going to look at a real simple example. Let's say I have a plenum height of 14 inches. So that means that the ductwork I can use can be no bigger than 12 inches high. We're going to say we have 1400 CFM. So whenever I actually start sizing the ductwork, the first thing I want to do is I want to make sure that my ductilator is set on the side that says English units. There's also a sizing for metric units. We want to use the English units. And we're going to be using rectangular ductwork. And there's two different places on here for the actual duct size. Down here, this green part here is for rectangular duct dimensions. Up here we have round duct dimensions. We're going to focus on this rectangular for now. We have no idea how to get onto this chart or this wheel chart. There's basically two different places that you can get onto it. You can either get onto it with this blue section, and we basically have two different values here. We have the air volume in CFM, which we know, and we have friction per 100 feet of duct. Now whenever we're using friction, we have been using 0.1 maximum for our diffusers, and it's very nice to be able to pick 0.1 for all of your duct calculations and have one consistent friction loss for the entire system, and that'll really ensure that you have a nice, well-working system. The other way that you can do it, again, we have air volume, which we know, and with this one you can choose your velocity. And I like to, just to show you, let's see where the two compare. So we're going to go with our 1400 CFM, and I'm just going to slide this, the 0.1, and line it up with 1400. You can see that the 0.1 is lined up with 1400 CFM. If I went over to this section without moving it, and I looked at my 1400, it lines up with 1900, I'm sorry, 1400, it lines up with almost 1,000 feet per minute. So either way, you can either use the pink or the blue. If you're using the pink, then you're going to let 1,000 feet per minute be your guide, and if you're using the blue, 0.1 inch per 100 feet. Alright, so back to the problem that we had. We had a plenum height of 14 inches, a maximum duct height of 12 inches, and a CFM quantity of 1400. So I'll line this, make sure this is still lined up. It is. I still have 0.1 lined up with 1400 CFM. And I'm going to come down here to my little green chart here. I could use any of these duct sizes. if I had a piece of ductwork that was 3 inches by 100 inches, it would have a pressure loss of 0.1. It would have a velocity of 1,000. But staying within the 4-to-1 ratio and knowing that square is my best option, I'm going to come down here and I'm going to look at where square would be. Basically 14 by 14, somewhere in that vicinity, is going to be my square option. I don't have 14 inches of height, so I'm going to have to go down to my 12-inch. So whenever I do that, I follow this line down, and I can see it's somewhere between 16 and 14. So I'm just going to go ahead and bump it up to the 16. I like to use even dimensions. That's going to decrease my pressure loss a little bit, but not significantly. So I'm going to use a 12-inch high by 16-inch wide duct. So my duct work for that is going to be 16 by 12 supply air. And we'll say that's coming from the unit. Let's say I have a branch. I'm not going to worry too much about that. I have a branch that dumps off 400. What's going to be left right here is, at this point, I'm going to have 1,000 CFM. So I'm going to go back to my ductilator, and I'm going to go up to, I'm going to use the pink side this time. I'm going to line my 1,000 up, use my 1,000 with 1,000. I'm going to hold it right there. You can see that 1,000 is lined up with 1,000. I'm going to bring it over here, and my starting point's going to be a little bit different this time, because I know that I'm going to keep my height the same at 12 inches. And the reason I'm going to do that is so that I can have a lot of height to have takeoffs. I want to leave myself a lot of room for my takeoffs, and what I'm going to do is I'm going to decrease my width. So I'm going to maintain a 12-inch height, so whenever I come back on here, that's going to be my starting point. I'm going to find 12, and I'm going to see what it lines up with. And it's somewhere between 14 and 12, so I'm just going to go ahead and I'm going to use the 14. So at this point, I'm going to have a 14 by 12 supply air duct. And I'm going to transition down to that. There would be a line through there, and this would actually be down here, 14 by 12. And that would be the start of my duct layout. And what you should be doing what you should be doing while you do this, start sizing your ductwork, is you should have this in front of you. And you should be checking these things and making sure that you're sticking with them. The other thing that you can do is I gave you 2 more sheets. HVAC ductilator, and it gives you a nice little breakdown of what everything is. We have the first one, CFM. We should all be pretty familiar with this by now. Cubic feet per minute, air volume. There's feet per minute. That's the air velocity. The friction is friction per 100 feet of duct, and it's in inches of water column, are the units. And that is basically measuring air resistance. CFM, how many cubic feet of air is coming in or out of a room per minute? This number is determined by your load calculation, how much heat or AC a room needs to stay close to the temperature set on the thermostat. Your feet per minute, how fast the air is traveling through the ductwork. Too fast and you have noise and vibration, too slow and poor fan performance. Your friction, if friction there is, the more the friction there is, the harder the fan has to work. The harder the fan has to work, the bigger the fan. The bigger the fan, the more space it takes up, the more electricity is used, more costly. And this is all review. We've talked about this numerous times. The duct size, round or rectangular, the size of duct that makes other three true. All four are directly related. So basically, if you change one thing, it changes another. Your air volume will always be your starting point. The velocity should stay around 1,000 feet per minute. And on this page, it just gives you some examples. And you can basically go through and use your ductilator and look at these just to see how the ductilator works.